Hello, everyone, and welcome. I'm excited to have you here today. We're about to explore some innovative solutions in flood management. The focus of our presentation is smart flood-resistant infrastructure technologies in Kerala. Over the next few slides, we'll look at cutting-edge technologies, their applications, and how they can help us build a more resilient Kerala. Let's get started. Kerala, as many of you know, is renowned for its stunning backwaters and lush, green landscapes that attract tourists and locals alike. But what's often less visible is its vulnerability to annual monsoon floods, which have become a recurring challenge. These floods not only disrupt lives, but also threaten communities and vital infrastructure. That's why understanding and developing flood resilience is so crucial for Kerala's sustainable future. In this presentation, we'll delve into some of the latest technologies and strategies that are being designed and implemented to help Kerala withstand these natural disasters. Our goal is to explore innovative solutions that can safeguard people, property, and the environment, making Kerala more resilient in the face of its ongoing monsoon challenges. Building resilience is a crucial aspect that directly aligns with global efforts to create safer and more sustainable communities. When we talk about Sustainable Development Goals, or SDGs, it's clear that addressing climate-related challenges is at the heart of this mission. One of the key issues we face is the increased frequency and intensity of extreme weather events, which makes proactive measures not just advisable, but essential. Adapting to climate change means we need to anticipate and prepare for these changes to reduce their impact. In practical terms, this adaptation helps prevent infrastructure damage, which can be costly and disruptive. It also protects agriculture, ensuring food security, and minimizes disruptions to businesses that are vital for local economies. All of these factors translate into significant financial costs if we're not prepared. That's why minimizing economic losses is so important. By investing in resilient infrastructure, we can save money in the long run. Above all, our priority must be protecting lives and livelihoods. Ensuring the safety of residents and safeguarding economic activities are at the core of our efforts. The need for flood-resilient infrastructure is especially urgent because floods are among the most common and devastating climate impacts. Building and maintaining infrastructure that can withstand these events is not just a technical challenge, but a moral one. It's about ensuring that our communities can recover quickly and continue to thrive even in the face of climate adversity. Let's talk about some of the key advancements in smart flood prediction systems. First, public alert systems play a vital role. They help disseminate timely warnings through mobile apps, SMS, and local media, which is crucial for facilitating quick evacuations and ensuring public safety. Next, hydrological modeling is essential. By simulating water flow and inundation patterns, these models allow us to forecast the extent and severity of floods more accurately. This helps us anticipate the impact and plan accordingly. Alongside these, real-time data collection is a game changer. Automated weather stations, river gauges, and rainfall radar provide immediate insights into changing conditions, enabling us to respond swiftly. Kerala is really leveraging these advanced tools, using meteorological data, satellite imagery, and ground sensors to develop sophisticated flood prediction models. All of these components, public alerts, hydrological modeling, and real-time data, work together to improve our flood response capabilities, ultimately helping us protect lives and property more effectively. Let's take a closer look at how technology is transforming flood management in Kerala. First, high-resolution maps play a crucial role in urban planning. They help us understand the terrain better and identify safe zones for development, which is key to minimizing flood risks. Moving on, geospatial mapping ensures transparency and efficiency when distributing aid to communities affected by floods. It allows us to allocate resources more effectively and reach those in need faster. Drones are another game changer. They can quickly assess damage in areas that are hard to access, providing real-time data that supports rescue operations and helps plan infrastructure repairs. This rapid assessment capability can save lives and reduce recovery time. Finally, machine learning algorithms analyze massive datasets to identify flood risk zones and predict which areas are most vulnerable. This predictive power enables us to make proactive decisions, potentially preventing disasters before they happen. All these technological tools, maps, drones, and AI, are interconnected and work together to build a more resilient Kerala. They embody the overall theme of using innovative solutions to effectively manage and mitigate flood impacts. Let's explore some innovative engineering solutions that help maintain connectivity during floods. First, modular and demountable structures are key. They allow for rapid deployment and easy repair of temporary crossings, which is crucial in emergency situations. Permeable pavements are another smart approach. By letting water infiltrate the ground, they reduce surface runoff and ease the strain on drainage systems during heavy rains. When it comes to bridge design, we're seeing improvements like longer spans, deeper foundations, and materials that resist scour, all of which enhance durability in flood-prone areas. Elevated roadways are also important. They're built on stilts or embankments to stay above expected flood levels, ensuring roads remain open when flooding occurs. These strategies, collectively, are vital in creating resilient transportation networks that can withstand extreme weather events. Now, let's explore how we can optimize urban drainage systems using the latest technology. One key approach is integrated drainage control, where smart systems dynamically adjust dam gates to manage water release effectively. This helps us prevent downstream flooding, especially during heavy rainfalls. Next, we have automated dam operations, which rely on deploying sensors throughout rivers, canals, and reservoirs. These sensors continuously monitor water levels, flow rates, and water quality, providing real-time data that informs our decision-making. All of this is made possible through sensor networks, which connect these sensors into a cohesive system. And at the heart of this entire setup is the Internet of Things, or IoT, a network that enables real-time monitoring and control of water bodies. Together, these technologies form a comprehensive water management system that's smarter, more responsive, and better suited to address the challenges of urban drainage today. When it comes to building resilient communities, innovative housing solutions play a crucial role. Modular and prefabricated homes, for example, allow us to construct and repair houses much more quickly after flood events, helping communities recover faster. Using water-resistant materials is another key strategy. These materials can withstand prolonged water exposure without suffering damage, which is essential in flood-prone areas. Amphibious architecture takes this a step further by designing homes that can actually float with rising water levels, providing a dynamic response to flooding. Elevating foundations is also critical. Raising structures above the anticipated flood levels ensures that homes remain safe and dry during severe weather. Altogether, protecting homes in these ways is fundamental to strengthening our community resilience. These new models of flood-resistant housing are not just innovative. They are vital tools in our ongoing effort to adapt and safeguard our communities against climate change and extreme weather events. Let's explore how employing robotics and automation is transforming the way we build flood barriers and structures. By integrating automated construction techniques, we can achieve higher efficiency and greater precision, which is crucial for effective flood defense. Running digital simulations allows us to test infrastructure resilience under a variety of flood scenarios, helping us identify potential weaknesses before they become real problems. Utilizing AI to analyze complex environmental data enables us to create accurate risk maps, ensuring we focus our efforts where they are needed most. When it comes to designing structures, precision engineering is key. Crafting structures that can withstand extreme hydrological forces requires advanced techniques and cutting-edge technology. All of these elements, robotics, automation, simulation, AI, and precision engineering, are indispensable tools in creating robust flood defenses. They form the backbone of a modern, proactive approach to flood management, aligning perfectly with our overall goal of building smarter, safer communities. Building resilience is not just about protection, it's really about empowerment. It's about giving communities the tools and confidence to face future challenges head-on. Kerala's journey towards flood resilience beautifully illustrates this. It shows how integrating smart technologies with forward-thinking urban planning and engineering can make a real difference. When we embrace AI, IoT, and innovative design, we're not just reacting to disasters. We're proactively building systems that can anticipate and adapt to the changing climate. This approach creates a future where communities are stronger, more prepared, and more resilient. So, as we look ahead, let's remember that resilience is about empowerment, innovation, and working together to make our cities safer and more sustainable for everyone.